Hello, everyone. Good morning. I hope you are doing well. I am also slowly recovering uh, from my sickness. Uh, Welcome to this first lecture on web APIs. So we will have three lectures in this part. Uh, Today, we will briefly talk about web and REST APIs in general. And then in the next two lectures, we will talk more about design of your APIs. Sorry, but more from the uh, linguistic perspective, or how you can design your APIs. Let's say the URIs, your metadata, the representations, and so on. So this part will introduce you with the basic concepts of REST APIs or web APIs. And then in the next two lectures will be more about designing APIs. So feel free to ask questions on either YouTube or Slack. I will be following Slack on my other screen, and I will also follow the chat on YouTube. So feel free to stop me and ask questions anytime. So let's begin then. So for this lecture and also the next two lectures, I will follow mostly these two books. In particular, for this lecture, I will focus on RESTful Web APIs book, the first one, where I will introduce some of the chapters. But for the next two lectures, I will focus more on this book, REST API Design Rule Book by Mark. So this book has a number of rules that that are good for your API design. Uh, I will also put some materials after this lecture, so including the slides and other materials you need or you could be interested to look at. And your assignment will be also based on this lecture. So you will basically implement some principles and concepts from this lecture, and also some design rules from this book, the second one, REST API Design Rule Book. As I was mentioning, we will have three parts in this web API module. So in the first part, we will talk more about REST APIs, HTTP, and introducing some basic concepts, resources and their representations, and so on. In the second part of the lecture, we will talk about interaction design, uh, how you can design the interaction between the servers and clients that are more meaningful, let's say, or semantically enriched, and also identifier design. That is one of the crucial part for implementing REST APIs. We do not often, as a developer, uh, care about the design quality of URIs themselves, rather than we focus more on the functionality of the APIs or the systems. So in this part 2 and 3, we will talk about how we can improve the quality of the APIs themselves. So in part 3, we will also focus more on how we can enrich our APIs with good metadata design practices, and also how we can design good representations of our resources. And we will conclude with some final thoughts and some practical concerns from the client. Uh, with this, let me see if I have any questions. So I will let's say regularly follow Slack or YouTube chat. So feel free to ask any questions. Uh, let's go to our lecture. So the first definition of web or World Wide Web or W3 was provided by Tim Berners-Lee. So in short, Tim BL. I guess all of you came across this name since he was the inventor of the internet or web. So he has this very first definition of web as a wide area hypermedia information retrieval initiative that aims to give universal access to large volume of documents. So if you look at the definition, there are three aspects or three focus areas in the definition. So the first one is hypermedia. So web is a hypermedia retrieval uh, system or a domain. Then you should have universal access to this document. Let's say a large volume of documents, so it should be open. And then of course the large volume or large universe of documents. So if you are working on an open network within your organization or within your department, that's probably not under the definition of in a web or internet. That's another concept of course, that's intranet. But then if you want your network to be connected to the internet, you should have open access, and you should have provide some kind of mechanism so that people can retrieve or search or find your documents or your information. And that mechanism is basically hypermedia. So in terms of web, hypermedia is one of the most crucial concept, I would say. So how this web came into the picture, or how it was introduced in the first place? Uh, it started in 1990s in Switzerland, and this guy Tim Berners-Lee or Tim BL, he had a project, a research project that was not for commercialization. So in this project, he basically developed several things that were that are basically first in the history. So this Berners-Lee or Tim Berners-Lee invented URI, he invented HTTP, he invented HTML. He also developed the first web server in the world history that is still running. So you can go to this website and you can still find this website, this server. You can still find this web server running. He also invented the first web browser and also the first HTML editor. That is, what you see is what you get. In short, is WYSIWYG. But development of these seven things or six things basically started a revolutionary era for information technology. So basically, we use URI as a syntax that assign each web resources an unique address or an identifier that is necessary for today. He also invented the HTTP. So that's a set of protocols or rules, and this is a message-based rules or message-based language that computer use to communicate each other over the network. Then he invented, as I mentioned, HTML. So this is the very efficient way of representing information that can be transferable over the web. So the web server, so if you want to access an application or a system or data or any other information over the web, you should put it somewhere. So this web server provides you whatever service you need or whatever data you need. So there was no concept of web server before Tim Beal invented. And then also the web browser. So now we have plenty of web browsers around, but before Tim Berners-Lee invented this browser, World Wide Web, there was no browser at all. And then now we also have plenty of HTML editors or text editors to write our code, whatever code we need. But there was also no HTML editor at that time also. So 1990s was basically the history-changing time for the world and for the information technology sector. And when we are talking about web, why web was necessary in the first place? One of the problem that web solve is the scalability problem. If you are using a private network within your organization, within your company or department, you have few number of users, you have few documents to share, you have few computers to connect, and so on. But when we are talking about internet or web, the scalability is beyond our imagination. Of course, the technologies that were developed or invented by Tim Berners-Lee was useful in the beginning, but then with the growing number of users, with the growing number of computers connected to the internet that are today's trillion or billion devices that are connected to the internet, scalability soon became a large problem. And this problem was not solved properly, I would say, by many other technologies beforehand, until this guy, Roy Fielding, in 1993, maybe even later, I would say early 2000, came up with these constraints or concepts that we also know as Fielding constraints. And these constraints are highly applicable to web to manage the scalability problem or to solve the scalability problem. And what are those constraints? Client server, uniform interface, layered system, and so on. So we will go briefly through each of those concepts, but based on these concepts, basically all our web applications, or not, if not all, most of our web applications these days are being developed. And when these constraints are present to some extent or fully in a application or a system or a web application, or even an API, let's say, we call them RESTful API. So to be RESTful, you need to um, conform or follow these constraints in your API or in your system. So out of those 6 constraints, the first one is client server. So we know that most of our systems these days, especially those that are web-based systems, though they follow this pattern, this style. So we have clients and server, and clients and servers has different roles. They are implemented using different technologies. They are deployed on different machines and so on, and they don't affect each other, meaning that we have high security, we have high modularity, we have a high scalability, and so on. And then, so this is very common concepts. And then we have uniform interface. That's the second constraint or group of constraints, and that is very specific to web APIs or RESTful APIs. And this is one of the very primary conditions for your APIs to be RESTful. And what are those? Uh, you should have resources in the first place. So I will talk about more about resources later. But your resources should have identifications. Without a name or without an identifier, nothing can be said as resources. Your resources should be represented or manipulated through some representations. It can be in any form. It can be text, it can be HTML, it can be PDF, it can be database, it can be an image, and so on. Then your resources or your representations should be self-descriptive. So your resources should have some descriptive information or data through which or based on which clients can proceed further, or client can traverse across different states of the resources or different representations of the resources based on those self-descriptive messages. We call sometimes them metadata. And then the hypermedia, that is the one of the primary conditions of your for your APIs or for your web APIs to be considered as RESTful. And also for your assignment, this hypermedia will be considered as one of the checkpoint. So if you do not have hypermedia for your application that you will be developing, you will not pass, I would say. So what is the hypermedia? So hypermedia is a concept or a strategy that you can implement using many technologies, many languages, and so on. But this provides the heart for RESTful APIs or applications that are resource driven, since resources might change over time. This hypermedia allow the clients or the users to connect resources or to move from one state to another state. Then it's as I mentioned, it's up to the clients or developers how they want to uh, implement this hypermedia. Then the third concept is the layered system. So similar to client server concept, these days most of the web applications or most of the applications are using this layered system. So basically we might have different proxies or gateways in between client and server to either provide more security or to serve more clients or maybe to uh, balance the workload between the servers if we have multiple servers. So security, response caching, and load balancing are few of the examples that those intermediary systems take care of. I already started talking about REST, but maybe I forgot to ask some of you. So, did some of you worked on REST APIs before, or did some of you developed any REST APIs before, following, of course, this kind of constraints? Perhaps these lectures, or at least this one, could not be new for you, or you already worked with REST APIs. So I found that some of you, yes, are writing on YouTube that you already worked on REST APIs with REST APIs. So people who are already familiar with REST APIs or worked with them, this lecture might not be exciting, but at least we will give you some refreshing memories for REST APIs. So the next three constraints include caching, then statelessness, and the code on demand. Caching, as I mentioned, can be achieved using layered systems, and it has many benefits, including it decrease the network bandwidth, it improves server performance, uh, it also improves the throughput for the clients, and so on. And although some APIs claim that they are RESTful, not all RESTful APIs mandatorily or obviously or taken to be granted implement this caching capability, because this is also a complex development effort for the developers. So a few developers, what we found based on our research experience, that they try to avoid caching because of the complexity, and they might, I mean, their customer base might be small, so they might not have that many requests to serve. So to make it simple and less complex, they tend to avoid caching. And then the statelessness. So this is also good for servers, because servers don't want to remember everything about clients, and if they had to, there would be service failure, or clients would not expect their responses as quickly as they want. And to remove these kind of problems, in REST APIs, servers are designed to be stateless, so they do not remember or store or capture any client data, including authentication data, including client states, and so on. So for each request client is making, client has to reintroduce itself or themselves, and this improves the API performance a lot, especially from the server side. And then also the code on demand. Um, we know that most of the scripts or codes, they are executed on the server side, in particular if the application or the services are deployed or developed in the server side developers. Sometimes there can be situation where server wants or server provides scripts that should be executed on the client machines. There are many examples like uh, JavaScript or Java applets or even Flash uh, things, but then it also improves the efficiency of the web servers. And if only if client ask for it, servers provide the scripts. And this is not a mandatory um, constraint. That's why most of the uh, RESTful APIs or API providers, they skip also this constraint. And this is one of the also least implemented constraint for RESTful APIs. Let me see if I have any questions so far. I guess no. And then we have a bunch of concepts that are very specific to REST APIs. And people who worked on REST APIs, I guess, I believe they already know most of these concepts. But for the sake of the lecture or for this course, I want to reiterate those concepts so that they are on the record. So, architectural constraint. So, what do we mean by architectural constraints? It's sets of not rules, I would say, but sets of principles that limit the behavior of a system. And if you put some constraint on a sets of systems, that means they are uniform in design and they are following the same design principles, in other words. So in REST, we saw these six design constraints that are known as fielding constraints. So those are the examples of architectural constraints because some of them are at the architectural level. Then we have caching. Caching is another important concept for REST that enables network-based systems or servers or intermediaries to hold some resource state. And whenever a client need that particular state of the resource, it doesn't ask to the web server, rather than it asks that intermediary server or intermediary system for that resource. So not all the request goes to the server, rather than some of the requests end up in the caching server, let's say. Then we have the entity body. We know that an HTTP message, it has two parts, so entity header and entity body. So here we have both of them. So the entity body have the actual content of the message, not the metadata or the communication information. So those metadata or communication meta information is stored in the entity headers. So they have their entity body and entity headers, they have their individual content and purpose. We will discuss more about those later. And then the representation. So what do we formally mean by representation? Representation is basically a formatted state of a resource. So it's a state of the resource, but it's formatted. Let's say if we have a resource in HTML format, it's represented using HTML specification. If we have a resource in JSON, it's formatted following the JSON specification, and so on. So representation should be well formed. So it's a formatted state of a resource. But then coming to the resource, so what is a resource? A resource, we know that can be any web object or web concept that can be referenced by an unique identifier. And when we are talking about unique identifier, that then it comes to resource identifier. So a resource identifier is a universally unique ID of a specific web concept. Uh, if we have billions of resources or trillions of resources over the web, all of them are uniquely identified. And we have another concept in that line, that is uniform resource identifier. So that I already mentioned. And then we have resource model. So resource model is basically a collection or assembly of interlinked resources or web-based concepts. Resources can be thought of an individual entity, but they can be also thought uh, of an interconnected concepts or interconnected resources. So when they are interconnected, in most of the cases for our applications, they are known as resource model. And in general, most of the web applications that follow REST constraints or that are RESTful, they have a resource model. Then another concept, resource state representations. And we already mentioned that uh, every resource have representations, and those representations are basically for a state, and that state of the resource um, should be or can be rendered using any form. It can be JSON, XML, JavaScript. It can be any document. And then we also have two other concepts, request message and response message. Uh, before I mentioned that we have HTTP messages which has entity body and entity headers. So those HTTP messages are basically request and response message. So when it goes from client to server, an HTTP message is a request message, and vice versa is the response message. Stateless, we already discussed what we mean by statelessness. So it's a REST constraint that restricts a web server or a application server holding any client specific data or client specific state. So a web server should not know beforehand what client is going to send a message or request. It will only know when a client sent a message and asked for a resource or something. Then the uniform interface, I think this is also one of the key concepts in REST. So it's a sets of 4 REST constraints that we discussed earlier that standardize the communication between the components. So it should have it should have a uniform. It should have resources. It should have uniform identification of the resources, and so on. So those 4 concepts. And the uniform resource identifier that was also invented by Tim Beal. It's a syntax. It's a concept, and the idea was again to assign each web resource or a REST resource an unique ID. I don't know if I missed any other concepts, or have you, or do you agree with all those discussions that I made? So people who are already working with REST APIs or worked before, do you have in mind any other concepts that are related to REST? Or did I cover all the concepts? I'm just looking at the YouTube or Slack to have your inputs. Okay, it seems there is no input so far, that which means I probably covered all the concepts that are essential in REST. So then let's move on to our next item. That is, so that was introduction to REST APIs. So now we will talk about resource and representations. So as I mentioned earlier, Tim Beal or Tim Berners-Lee invented some concepts, and out of those concepts that he invented, three concepts are very core to the web. So they are very important for web technologies. So URL, the HTTP, and HTML. And two other concepts that also rely on these technologies is resources and representations. So resources can be anything that can be referred as a thing. It can be any e-documents. It can be a database itself or database row or even a single data item from a row. It can be any algorithm or operation. For example, when we are implementing code on demand constraint and the server is providing a script to the client for execution, that script might become a resource. One of the essential constraint for a thing to be considered as a resource is URL. So without an URL, um, nothing is resource, or nothing is considered as resource. And if you have anything and you give it a URL, it becomes a resource. So both way are true, and both way are followed in the REST world. Then the representation. So representation is basically machine readable presentation of a resource. If your resource is not machine readable, then it's not considered as a resource, because also for hypermedia, if you are making transitions across different states of your resources, you are basically consuming those resources automatically, meaning that using some machine level processing, not by human intervention. So your resources should be machine readable. And we know that there are tons of representation format that are machine readable. I just listed a few of them, but there are many other types. So it can be any format, the resources or the representations of the resources. So here is an example of resource and representations. But let me go back a bit about resources and representations, because I mentioned that resource has representations, but then those resources and representations are transferred back and forth between clients and servers, right? So clients send a request with a resource to the server. Server process that request and send a response with probably another resource or another representation of the same resource that client sent. So two representations of the same resource can be completely different. And one of the thing here is that when we are sending or asking resource, we're not sending. When we are asking resource using a get method, we have a resource. We will get a resource. We may work on this resource or modify this resource, but then we are sending a post request or put request or patch request with that modified resource, right? So the idea here is that the get request does not modify the get request itself, does not modify the resources or does not work with modified resources. Rather, post, put, and patch, and maybe others, they work with modified resources or they modify the resources. So that's the two groups of or two classes of HTTP request. So here is an example. So let's say a client is, so these examples are also from the book. So a client is creating a new message, sorry, or a new post to this website where this representation or this resource is represented as JSON, and as a body, client is sending this message for this post request. So this resource has a very simple representation, as you can see. But then when the client is asking the same resource that he created on the server side, if he's asking that request, that message, so basically when this request was sent, the server created this message or resource and sent the link to the new location or the new URL of that message to the client. So clients now know that what is the URL of the new resource that he created. So this is also an example of hypermedia. And then client can ask for this resource to the server. And when client asks this resource to the server using a get method, as you can see, now we have a different representation of the same resource. So the thing I wanted to mention here that the same resource might have different representations based on the context or based on where it is being sent from and where it is being sent to. Any questions so far? Okay, so there was a comment on Slack that she thinks we can all remember that. And as I mentioned, yes, since many of you worked on REST APIs, this might be little boring for you, or already maybe you are familiar with those. But for the sake of the course, or for the sake of next two lectures, I'm introducing the background basically. So the protocol semantics of HTTP. So far, we are talking about HTTP methods. We are talking about resources. We are talking about resource representations. We are also talking about client interaction with the server. But there is also another important design thinking, I would say, for web APIs or for RESTful APIs, that is the semantics of the protocol or the semantics of the communication protocol for HTTP. Because we know that a resource can be anything, right? And a client can make any request. but client should not have the freedom to ask anything it wants in any format, or let's say uh, the general principle is that we create a resource using post and we update a resource using put. Client cannot use get method to create a resource or update a resource, or client should not use a put method to create a resource, and so on. But then these sets of rules in HTTP are usually known as semantics, or protocol semantics, if we want to follow them properly or accordingly. In general, HTTP has 8 different standard methods. So get, that we probably use the most common for get, delete, post and put. But there are 4 other standard methods. So head, options, connect, and trace, that we probably don't use that often. And out of those 8 methods, we have 3 other uh, non-standard, I would say, HTTP methods that are particularly useful for REST APIs. So they are patch, link, and unlink. So the first 4 basic methods, we know they are used to create or modify resources. Then head and options are to explore resources. But this link and unlink methods, although they are new, they are very useful to deal with resources. Let's say if you don't know anything about an API, and you want to create from scratch a resource model for that API. So in that case, this link and unlink methods are useful. So you can use them to create a resource model out of nowhere. Then we have two types of semantics: application semantics and protocol semantics. So the protocol semantics are related to those HTTP methods, or both standard and non-standard. So the protocol semantics basically say we should do with an HTTP method what is meant to be done. So we should use HTTP methods properly, in plain words or in simple words. So that's the protocol semantics. And what's the application semantics? So in the application, we might have different commands, different buttons, different text box, different actions, let's say. So this protocol semantics and application semantics should be consistent and coherent, meaning that, for example, I have here 2 examples. I have a button in our application, in our web application, get a blog post. So that button, if from the application side, it means that get a blog post, from the protocol semantic side, it should get a representation of that blog post resource, and it should not do any other things. In the second example, if we have a button, let's say, update a blog post, it should change the representation of that blog post based on the user input. So it should not do anything else other than update. So both of these examples, as you can see on the left side, we have application requirements or application functionality. And we have on the right side, we have protocol semantics or protocol functionality. So those should match. And if they don't match, that means you are not using the HTTP protocols properly. Or in other words, you are lying to your clients, I would say. Yes, and then for the protocol semantics, uh, I mentioned there are eight uh, standard methods, HTTP methods. I will go through each of them and briefly highlights their properties. For example, the get method, it's a safe method, and it should be used only for retrieving resources. So I guess you also know what do we mean by safe method. And safe method are those methods that do not alter uh, a state of the resource on the other side or on the server side where the resource is located. There are also unsafe methods like delete. So basically, delete is an unsafe method that alter or even remove the resource basically. So it changes the state of the resource. It doesn't exist. There are different types of response code also in HTTP. I think I will come back to that later also. And these HTTP codes, they are also part of protocol semantics, meaning that your communication between server and the client should be semantically correct. There is one concept called idempotence or idempotent. So some of the HTTP methods, they are idempotent and some are not. And this concept comes from the mathematical area or for mathematics. Basically, the concept is that whatever numbers we have and how many times we multiply that number by zero, it will be always zero. So the uh, state will never change. I will I think show some example there later. Uh, so if we the idea here is that if we do some actions on a resource multiple times, it should not uh, change the it might or might not change the state of the resource, but if it does not change the state, then it is known as an idempotent method. If we make, for example, a get request 10 times on a resource, it will not change the state. That means it's idempotent method, the get method. Whereas if we call the put method even two times, even one time, it will change the state of the method or sorry, the resource, or it will change the not only the content but also state of the resource. One important thing to remember is that all safe methods, they are by default idempotent, but not the vice versa. So not all idempotent methods are safe. Some of the idempotent method can be unsafe. For example, the put method. Then there is another very common method, post method. I am saying very common because these are the two very common methods, get and post, that most of the developers uh, tend to use. So they always try to use get method for retrieving a resource, and then they want to use post method to do everything else. So that's why there are two use of post method. One is post to append, that's the natural use of post method, and then there is overloaded post. This overloaded post is a simple solution. Let's say if you are handling your hypermedia using HTML. But then, although this is a simple practice or simple solution to use post for everything, but then it breaks the protocol semantics of HTTP. So you should not do it, although it's possible to do it. But there are some constraints also. For example, for the HTML, it doesn't allow put method to update a resource. So that's the reason the developers try to use post method for both creating and updating a resource. So this post method is also an example that is not safe method and not also idempotent. So why it is not idempotent? Because it's creating a resource, and every time you create a resource, you will get a new ID of the resource. Basically, you are duplicating your resource. So if you send a post method underneath or with a current resource, so what usually we do, we make a post request, we put a body for the post method, and we ask the server to create a resource. So right, so this post method, if you invoke or send 10 times, it will create 10 different resources. So this is not idempotent. And then the put method, this is also another method that modify the resources. We can also modify resources using patch method, but then if you are modifying a resource, you should also send a body with this put method, similar to post method. But if your body does not match to the representations of the resource that is already stored in the server side, you might get a reject response. Or let's say the resource that you are trying to modify in the server side, that is read-only, you also might get a reject response. And then there is a patch method. So usually, if we want to update only a part of the resource, because resource can be very big, then it's good to use patch method. And if you know the specific difference between the two resources, you can update that part of the resource. For example, if you have a large JSON and you know which key value from that resource will change, you can update that part of the JSON using this patch method. And also similar to post method, this is not safe, meaning that it will change or alter the resource state, and this is also not idempotent. So it will every time make a changes to the resource every time you make a request. And then there is this four. So not four. I think two non-standard method, as I mentioned, link and unlink. This link and unlink are very specific for REST APIs, although they are not safe, but they are idempotent. So they are basically not changing, or basically every time you make a link request for a resource or for two resources, every time you get the same result. So you basically get a connection between these two resources, because using link method, basically you are saying that these two resources are related or they are connected. And then we have these two other standard methods, head and options. They are also useful because, for example, if you want to just get the metadata of a resource, you can use this. You can get this using this head method instead of using a whole get method, because using the whole get method gives you the entity body also that will need that might need lots of bandwidth. But if you use this head method, you are basically getting only the headers information and not the body. And the option method is also another way to explore the REST APIs. So as I said, I mean, if you want to create a resource model of an web API, you can use this method like link, unlink, and option method to explore the API and create a resource model using the link, for example. And this options method uh, gives you which methods are or which request can be made on a resource as part of this allow header, HTTP allow header. So this HTTP allow header contains those methods that are applicable for a certain resource. Okay, I think how long we had. So we have already had 1 hour. We can have a quick break of 10 minutes, and then we can come back for the next part of the lecture, that is which about hypermedia. So let's take a quick break, and then we can resume our discussion. So see you. So what's the time now? See you at 11:25, let's say. Okay, I think we can start. I got a question also from on YouTube. Let me show you the question here. So, what do you think? No. So, what's your take on 404 or 204 response when it comes to not disclosing information during unauthorized request? Would you go for 404 or 204 as a response? Uh, and then there was a counter response on that. Uh, yes, and to add that question, a general 500 or being more specific and revealing what the problem might be using 5. Oh yes, I think I agree with Elena. And usually the group of 200 uh, access code are for good reasons rather than bad reasons. So in the alternative way, you can use 404, but I think 204 here is not relevant at all, since this is a success code with no content or not content, something like that. So let's resume our previous discussion, and we wanted to talk about hypermedia now, and I will try to go a little bit faster because it seems it's taking more than expected, the time. So hypermedia, and were already discussing uh, hypermedia a bit, but hypermedia really uh, allow you, or let you know which protocol semantics basically does a server support on a URL. In other words, what you can do on a resource. And in other words, hypermedia basically connects resource and their capabilities. So one of the way, or one example of that is, for example, you send a get request, you get the resource, and and a representation of the resource, and in that representation you might have links to the current resource and also links to the subsequent resources that the client can follow or traverse through. So this is one example of hypermedia. And as I mentioned earlier, hypermedia is not a technology, or it's not a mm, language or editor. Sorry, it's a strategy or it's a method, and you can use any technologies to implement hypermedia. And here's the two examples of HTML hypermedia, or HTML as a hypermedia format. So you can use any other technologies. So you in HTML, when you are putting a link, it can be any link, and a text to show that link. When the user click on that link, behind the screen, it's basically a get method based on which a client retrieve a resource from that web server or from that host. So this is a very simple hypermedia example. And another example can be using this image control tag from HTML, where you put a location or URL of that image. But the difference between this first example and the second example is that in the first example, you might need an user action. So the user might need to click on the link to make that action happen, or to make that get request happen. But in the second example, the user don't need to click anything or don't need to do anything. So the the client or the web browser silently go to this server, so example.com, and retrieve this logo.png and put it in the place for the user. So these are two examples of hypermedia. Some of them might need some action, some of them might not need any action. Hypermedia can be also more complex. The example that I showed you was a GET request, but hypermedia might have other requests. For example, here it shows a POST request. So it has a text box, it has a button. So based on the values in the text box, when the user click on the button, it basically asks the server, or send to the server a POST request to create a new resource under that resource that we mentioned here. So basically, you type it, we post it.com/messages. So under this resource, a new resource will be created based on the input in the form. And when the user is clicking this button, it sends a POST request. Basically, what it does, it creates a POST request like this, and the URL that will be sending as a POST request has this message as a body. So the message equals to hello, and the value of the submit is post. Then the server understands that, okay, this client is asking me to create a new request because we are specifying the post method here. Yes, and then in this way, there can be other HTML tags that we can use to create or to modify resources. We shown the example of hyperlink tag. So the A tag that a user can use to get a resource based on user action, or based on the trigger from the user. There is also image tag. That is also another example of get request. But you don't need a user request for that. It automatically happens behind the scene. Then there are two use of form. So the example that I shown in the previous slide is a POST request using the HTML form, but there can be also a GET request for the HTML tag form. So the POST request usually is user triggered. It can be based on the button or any other link. But then this get method also can be user triggered, and it doesn't modify any resource or create any resource. Simply it gets a request. It gets a resource from a specific or custom built URL. But talking about hypermedia, there is this, I would say, first definition of Roy Fielding in his thesis also, where he proposed those 6 constraints. So hypermedia basically is the presence of application control information along with the information for the that are presented. Basically, you have application control plus you have the information, and these two combinedly becomes an hypermedia. So in this case, we have application control information, let's say a tag or image tag or form tag, and those include some information or presentation of information. So combinedly, these tags or the HTML document can be considered as an hypermedia. I hope I could make this clear. Then there is another concept, URI templates. URIs can be constructed in two different ways or multiple ways. Sorry, I still have some problems with my voice because of maybe the COVID. But so out of these two representations or two URL design, which one would you prefer, or why? Any input from your side? Let me see if you have any thoughts on this. No thoughts yet? I think it's a little bit behind the live streaming and the time I'm speaking, so sometimes it's delayed, the response on the YouTube chat. But if you were designing a REST APIs that is based on resources or the concept of resources, I would prefer the second design, URL design here, because it's a hierarchical representation of resources that is well supported by HTTP and REST design guidelines. So this URI templates, it's also a hypermedia technology that is defined in RFC 6570. So there are many standards or many standards or specifications, I would say, in the RFC 6000 series related to web and web technologies. So so URI templates is one of them that is defined in 6570. So what is URI template? So this URI templates basically describes a request to the URL. For example, in this case, the URL is you type it, we post it.com / messages and / then there is the request part. So this is the part where we either can put our values or our variables depending on what request we are sending to the server. For example, if you can see, the variables can be represented like this, and then later when we are making the request, we are giving a value to this variable. So this kind of URI templates, basically URI templates are that they include placeholders for variables within the URL, and that becomes a URI templates. So those kind of URI templates can be represented in HTML. So you have the same get method, you have the URL, and then you have the variable part of the request. So you have the input text form. Then based on the action taken by the user, so in this case, let's say the search action, whatever value the user will put in this text level will be used as part of the URL here. So it will be sent to the server. So basically, this is the representation of this HTML hypermedia if you are using a URI template. So slash messages slash then the value of the query part here is the query. So this query comes from basically here, and the ID is coming from also the Hypermedia HTML Hypermedia. So these are two same representation of this HTML Hypermedia that can be represented using URI template. And I think these URI templates are also these days very common in sending requests to the servers. But then there is also another concept, the difference between URI and URL, and we are familiar with URI. We are also familiar with URL, but the main difference is that there is, I mean, URI might not have, so the resource the URI is referencing might not have a representation, but the resource that a URL is referencing must have a representation or a representations of its current state. So a URL can be used to dereference a value, a resource or value or anything, meaning that you can use your URL to locate or retrieve a resource, but you cannot use URI to retrieve or locate a resource. And URL is basically a combination of the protocol and the URI. So the last part or the second part of an URL is the URI, and when it is combined with the protocol, and the protocol basically says that how that resource will be accessed or how that resource will be retrieved. So when we combine these two, it becomes an URL. So here is some examples. For example, this is a URI of a book, but then this is not the URL. But when we combine this URI with a protocol, it becomes a URL. And according to the REST principles, no URLs means it cannot be represented, so there is no representation. And if it cannot be represented, or if there is no representation, that means user cannot transfer or user cannot move from one state to another state of the resource. That means there is no representational state transfer. And if there is no representational state transfer, that is also the core of Hypermedia, then it's not RESTful at all. So yes, be careful in your also project or API design to have this Hypermedia. And I think this is also one of the major requirements for the project, to have Hypermedia in your API solution. So we are talking about Hypermedia. So Hypermedia is all about guiding the request, like telling the clients what HTTP methods to use, what URL to use, which headers to use, and do you need to send an entity body or not. So here are two examples. So in the first example, that's a GET request. So that's another example of Hypermedia using a tag. So it specifies the target URL and the HTTP method. But in the second example, as you can see, we are not only specifying the method or the URL, but we are also specifying the entity body of the request. So when the user is searching or looking up a address, it's using that text input from the user in terms of store name and the city name. So these are two examples of hypermedia and how or what it needs to make a request, because different requests might need different information, and hypermedia allows you to include those information in your request. Okay, so this is the last part of today, and we will talk about HTTP and basically HTTP for APIs. From the technology perspective, uh, we have resources, right, for RESTful APIs, and each resources are identified by an URL that says where is the resource located, and then those URLs or those resources are accessed by a protocol. That means it can be FTP, it can be HTTP, it can be HTTPS, and so on. And then those protocols are telling you how to access those resources or how to access that server. And those are made possible basically using this hypermedia, because hypermedia gives you the protocol semantics, meaning that which method you will use, which URL you will talk to, which protocol you will use, and so on. So HTTP sits on top of URL, and hypermedia sits on top of HTTP. And when we are talking about hypermedia, that means it includes the HTTP and it includes the URL. So that's the basic technology stack for WWW or even for RESTful APIs. So there is a new, not new, I'd say, but the HTTP 1.1 specification, because there is another latest specification that is, I think, HTTP 2. But the current one that is mostly used is HTTP 1.1, that has a wide range of response codes and wide range of headers. So this response code and headers are also a critical or integral part of protocol semantics. So without them, either you are not communicating properly with your clients, or you are communicating false information or improper information to the clients. And unfortunately, developers do not use those response code most of the time. They either ignore the response code, or they use very small group of small response code rather than exploring other response code. And it's never good to create new response code or use a unknown response code. So it's always good to use those 41 response code that are already defined instead of reinventing the wheel. And same for the headers. We sometimes find that based on the studies on the real APIs, we found, for example, Facebook or Dropbox or many other APIs, we found that they have sometimes defined their own headers, which is also a not great design practice or development practice. Try to use those 47 standard headers that are already defined for HTTP instead of creating new headers that might limit the consumption of your APIs, or clients might have difficulties to understand your APIs or even use your APIs. So out of those 47 REST headers or HTTP headers, and that are also part of request and response, content negotiation and conditional request are highly useful for the REST context. So you might not be interested in all 47, but check those that are related to content negotiation and conditional request. Those will be helpful for your REST APIs. Then there is also multiple representations of resources. One resource might have many representations. The same text message can be represented in text file, in XML, in JSON, in RDF, and so on, or in many other formats, even as a database entry. So it depends also what level of representations you want to give to your client, because representations can be either very detailed or it can be an overall representation or overview representations. I think I gave some example, one example in the very beginning, when client is creating a blog post by sending a message, and then when client is asking the same blog post that he created next time, the representations vary a lot. So the server sends much more detail than only just the message. But the problem here is for the client. So how he wants to manage, or how he knows that which representations he wants out of multiple representations. And there are multiple ways of handling that. One of them is content negotiation. As I mentioned in the previous slide, that content negotiation headers are highly useful for REST API designers. And for that, there is multiple accept headers defined as part of those 47 request and response headers. So one of the example is the client might say, I accept JSON. Alternatively, client might say, I accept either either HTML, or I can accept XHTML, or I can accept XML. So when client is mentioning multiple representations, that means he prefers first the HTML. If it doesn't exist, then he prefers the XHTML. If it doesn't exist, then he accepts the XML. And there is the value. So the higher the value has the higher priority. In this case, for example, the client want XML with a Q value of 0.9, and then if nothing exists, so if the server doesn't have HTML, server doesn't have XHTML, server doesn't have XML, server can send any version they have or any representation they have, but with a lower priority. So the priority here is first the HTML, and then if nothing happens or doesn't exist, then any version they had or the server had. The client can also mention which language they want by using accept language header. So in this case, for example, first he accepts the US English, and then if it doesn't exist, then any other English, but with a lower value. And if the client request is not accepted, server sends, let's say, 406 not acceptable response if certain requirements is not met. Client can also know which representations it wants using these hypermedia menus. So when this happens, servers basically send a response with this 300 status code and a number of links in the entity body, and then client can choose whichever representations it want. Then performance is a big issue for HTTP, and especially if you are designing REST APIs, you want to optimize the performance by the server. And for that, you have several ways to optimize. One of them is the caching. We already discussed caching. Then the conditional get. I will discuss, I think, later more about them. The compression, so we want our resource representations in compressed mode rather than plain text mode or plain XML, for example. There is also partial get, so you retrieve only a part of the resource if you have a large resource and you don't need all of it. And then obviously the pipelining, so you can send multiple requests under multiple resource requests under one request. So let's say you can send 5 get requests within one click or within one access. So the first one is the caching, and the very well-known or commonly used approach is to use this HTTP header cache control, where the server sends this information to the client that a resource representation is valid for certain number of seconds. So in this case, the server is mentioning or telling in the HTTP header that cache control max age equals to 3,600 seconds. That's like 1 hour. So this validity of 1 hour applies to entire response. So it applies to headers, it applies to response code and the entity body. And if the server does not implement caching, it can simply say that cache control is no cache. And we also found sometimes, not sometimes, I would say many times, the API providers, they don't implement caching. Again, this is also for complexity, because implementing caching takes time and effort for the server-side developers. So this is one easy way of getting rid of caching. But we should use cache if we claim that our APIs is RESTful. Then there is a conditional get request, and it's highly useful when basically you are retrieving the same resource multiple times, and that same resource might not be volatile, so it doesn't change that often. So if something is not changing that often, one way is of course not to bother servers every time is to use the caching. But if you want to bother the server and you want to get the recent data, one way is to use this conditional get request, where if you make a request, the server sends a HTTP header called last modified. That is the last modified date for that resource. And when using the same information that server provided, when the user is making another request, he's using this value for another HTTP header, that is if modified since. And then if the request is modified, the server will respond with 200 OK. And if it doesn't modified, server sends 304 not modified, something like that. So it saves both the time and the bandwidth, especially the bandwidth. That is helpful. So this is one way to optimize the performance of the HTTP or of your REST APIs. Another way is to do the compression, and that is also very useful. So when the client is making a request, it can say to the server that I want or I accept gzip, because let's say I have the implementation of uncompressing a compressed file for which that is compressed in gzip, or I have the tool for this gzip and so on. And the server responds, let's say, okay, 200 okay, and sends the request, sends the response or the representation in gzip. And the server, in addition, also mention what is the content type when the representations or the resource will be unzipped. So it will be basically an HTML. And this also sends significant bandwidth. Another way of optimizing. Okay, I think I did not mention these two. So partial get and pipelining. So I just briefly mentioned them. Like partial get is when you want to fetch a part of the resource, and you don't need the full resource if it's a long resource, a large resource. And then pipelining is when you're sending multiple requests under one session or under one click. But what I'm discussing now is the authentication, because this is also important in REST APIs. And I think also for your assignment, authentication is mandatory. So you need to implement one of the authentication mechanism. Of course, Oauth is desired, but you can also choose for basic auth depending on the requirements. But I think you already know about Oauth from other courses, so you should implement or pick Oauth for your authentication of the APIs. So there is a three basic mechanism for authentication. So basic auth, Oauth 1 and Oauth 2. Basic auth is simply user and password based approach, where a code is generated or value is generated based on your user code and password. I think I have slides for all three of them. Yes. So basic auth is the simplest form of authentication. You have a user ID and password for the resource server, or where the resource is located, and based on your username and password, you basically get a value or token that you will use every time you want to authorize yourself. But there is problems with this basic auth, and that is why it's not recommended. The problems include that it's not secured, so anyone who is listening to your connection can get your code or value, and then easily decode it and get your username and password also, because this value is simply an encoded version of your username and password. And that's why people don't usually, or should not usually, trust their clients, because this client can be a fake client. To solve this issue, there is a new authentication mechanism, that is Oauth 1 and Oauth 1. And basically, the idea here is that if you have one client, that's not a problem. But if you have multiple client, what you can do, you can give different credentials or different token for your clients. And even if one clients fail, your other clients will continue accessing the website or the application. So here is the official definition of Oauth 1.0 in the specification, that says this Oauth 1.0 allows websites or applications that are basically consumers to access protected resources from a service provider or the web service via an API without requiring users to disclose their credentials to the consumers. So as a consumer or the browser doesn't know our credentials, rather than he has a token that on behalf of the user request resources from the server, or from the request resources for the protected resources. I mean, protected resources are those resources that you need to be authorized to access. Not all resources are open. So there are two versions for Oauth, 1.0 and 2.0. 1.0 was originally proposed when you are, let's say, doing some e-commerce or purchasing something from a website, or opening, let's say, an account on a government websites and so on. So it's basically websites based that are particularly designed for consumers. But then there was a problem for Oauth 1. Although it was working well, instead of working based on the username and password, it was working based on the tokens. But the problem were when the new era of computation and software development came. So when there was mobile applications, when there are desktop applications that run on browser and so on. So that became a problem for Oauth 1.0, and thus Oauth 2.0 is introduced. So in Oauth.1, there are two kinds of token. So for your project, you can choose any of the Oauth 1.0 or 2.0. But again, you are recommended to use Oauth 2.0. So, but in Oauth 1.0, there are two types of token. One is the request token and one is the access token. So this request token is authorized by the user for the consumers on behalf of them, that authorize access to the resources for the consumer, and then consumer get another access token from the authentication server to access that resources on behalf of the user. So there are two steps basically for the authentication 1.0. One is to get the request token, and one is to get the access token. So this is how a simple authentication work using Oauth 1.0. So the consumer gets an request token that is not authorized, that is unauthorized, because that is not authorized yet by the user. So then the user authorized that request token, and once the user authorized that request token, the consumer used that authorization to get an access token, and based using that access token, basically the resources are accessed. And the good thing here is that even the request token is compromised or expired. I mean, if it's compromised, the fake consumer or fake client cannot have that access token, um, and cannot access the resources either. So that's why it's more secured. But then to improve this Oauth 1.0 further, since there are mobile phones, there are mobile apps, there are desktop apps, they are running on the browser these days. That was not the case earlier. That means you are not only in the browser, you are in different place, and uh, you might need to authenticate yourself from different devices, different places. And that's why this Oauth 2.0 is useful. But in Oauth 2.0, they are also have other uh, concepts that are unique to it, like resource owner, resource server, authentication server, and client. They have their different roles and responsibilities in authenticating a consumer. And I think there was a question in the YouTube. Do we need to use OAuth, or can we implement our own authentication mechanism with Jwd tokens as stated in assignment? Yes, I think I forgot this about Jwd tokens. So you can also use these tokens, the Jwd tokens, but I do not recall at this point, but maybe OAuth was also recommended if you want to uh, use it purely. But I think the default requirement, or at least you need to implement, is Jwt tokens. Yes, you were right, Daniel. I did not remember this one. Okay, so we are also running out of time. I think this is my last slide that shows a simple mechanism of how authentication Oauth 2.0 works. Basically, what it does is the client make an authorization request, and the resource owner grant the authorization, but this can be granted in multiple ways. And then based on this grant, the client also asks for the access token, and based on the access token, basically it's get the access to the resources. But that authentication grant, there are 4 different types of authentication. So one is the authentication code that is provided or handled by the authentication server as an intermediary server between the client and the resource owner. And then there is also implicit authentication grant. So the client is directly asking the resource server an access token. And then there is also a regular password based credentials. So the client can use a username and password to obtain an access token from the resource server, and then also the client credentials. So when the client is basically asking itself or on its own behalf the credentials or the access, in this case, because the client is also owns the resource itself, so it doesn't need to do this kind of back and forth to get an access token. It can simply use its own credentials. So I think that was it. And if you have any questions, we can discuss now. If not, then I guess the next lecture will be on next Wednesday, if I'm not mistaken. And that will be more about design part. So I guess you are less familiar on that part that we will discuss next week. So any questions from your side? If yes, if not, we will see you next week. But I guess, let me see. There might be some tutoring this week also. I'm just checking my calendar, and yes, there is a tutoring on Thursday. Thursday from 15:15 until 5. So I will let you know how to book your slots, or how can we meet for the tutoring session. So on Thursday, that is tomorrow, we will have a tutoring sessions from 15:15, and if you have any questions, you can join in and ask your questions. There was some questions about authentication from Tamim. Oauth, does it require integration with third party? It's up to you. Obviously, if you do it, it's more complex. But for the assignment, try to keep it simple, and a simple Jwd tokens or simple Oauth authentication should be enough. Do we? Daniel said, do we have any reading materials for this week? Yes, but I will put those reading materials right after this lecture. Not much from the books, but if you follow the slides, or the books that I mentioned in the slides, should be enough. But I will put some reading materials. Yes. Okay. So Tamim was mentioning about Facebook or Google. Yes, I mean you can use those for Oauth authentication. Because you need an authentication server anyways. If no more question, then see you tomorrow for the tutoring, or next week for another lecture. Have a good day. Bye bye.